Hello, everyone. Thank you for joining the webinar. We're going to wait just a moment for a few more people to join. Okay, thanks to everyone for joining. I know that we still have some people joining, but we're going to begin in the interest of time and respecting the time of those of you who have joined already. Just for some context here, in December 2020, the pandemic is making a lot of our lives quite dark and difficult these days, but the vaccines are providing a light at the end of the tunnel that reminds us of the central importance of the chemical sector and science in our daily lives. At the same time, the rapid development of these highly effective mRNA vaccines over the past 9 months shows that we can achieve great things when we put our minds and resources towards something. So I think this is a very exciting time to be working on the chemical sector. There's a lot of rapid changes happening in the sector. And I'm very pleased to have all of you join us today for our Science-Based Targets Initiative webinar on setting science-based targets for chemical companies. The Science-Based Targets Initiative was founded back in 2015, and it's a collaboration between WRI, CDP, the UN Global Compact, and WWF. And today's webinar is the end of a year-long project that we've been doing on scoping for the chemical sector. The next slide just provides some housekeeping details here, which is to say that this webinar is being recorded, and as always with this project and the webinar, we do intend to comply with competition laws in various jurisdictions. That should enable everyone to participate freely. The recording of the webinar will be publicly distributed via email and the project website. The next slide just gives an overview of who's presenting today. So I'm Nate Aiden. I'm a senior fellow with WRI, and I've been leading this project over the past year with my colleague Kylie Chang from WRI, and we've been very fortunate to have the technical assistance of Michiel Stork from Guidehouse Consulting, where he's an associate director and chemical industry specialist. The next slide gives an overview of the agenda for today's webinar, and it's fairly brief at just an hour long. And so I'll begin with an overview of this chemical sector scoping project, as well as a brief overview of the initiative to give you some context for what we found during this project. And then we'll provide a summary of the stakeholder survey that we conducted this past summer and some of our thoughts for how to respond to the issues that were brought up in the survey. And then two of the key issues that have come up consistently are the chemical sector boundary, insofar as many companies use inconsistent or uncertain boundaries with regard to their scope 1, 2, and 3 emissions. And then another key issue here is the end of life emissions for chemical products. Given the high chemical sector feedstock use of fossil fuels as opposed to energy use of fossil fuels, there are significant end-of-life emissions depending on how those products are disposed of. And so this is one of the areas that has been focus for the feedback and in this scoping project. Finally, we'll toggle back to me with some some next steps discussion for where we see this project going. The next slide just starts to transition us into the project. So, a question here is why chemicals sector? And when I opened the webinar, I talked about how it's central to our daily lives nowadays with the vaccines. Certainly that's the case, but even beyond that, before this pandemic, the chemicals sector has been central to our lives for more than a century and really enabled our current societies. Not only is the chemicals sector the third largest industrial subsector source of greenhouse gas emissions globally, but chemical sector products are pervasive and used in every sector of the economy. So this has always been an important area for the Science-Based Targets Initiative. And it's one that has come up consistently with other sectors, Scope 3 targets and supply chains, where many other companies are sourcing their input materials from the chemical sector. And so they're already engaging chemicals companies to set targets. But we wouldn't have been able to actually perform this scoping project without the very generous support of 3M Foundation. So we gratefully acknowledge them and just mention that this project is really intended to serve chemical companies as well as industry associations and broader stakeholder audience, including investors and other groups. The next slide gives an overview of the project timeline. So you can see that this scoping project has been over the course of this calendar year. We began in February, and initially we did some scoping. We assembled an excellent expert advisory group, which has been very helpful in helping us to identify key issues and options for addressing these issues. And then over the summer, as I mentioned, we conducted a stakeholder survey, which was completed by 59 people and was very helpful for identifying what the key issues and priorities are for chemical sector companies and stakeholders. Now, the purpose of this webinar today is to summarize our findings during the scoping project and introduce this scoping document that we are going to send to all of you and distribute within the next week, which summarizes key issues and also some options moving forward. So this is sort of the outline of this year's project, and we hope that it will lead to further work. And that's really the sort of orientation of this work, is that we don't have infinite resources. We don't have a good sense of everything that's going on in the sector. And so this is really helping us to prioritize our resources and work for next phase work and for potential method, criteria, and guidance development for the sector. So the next slide just gives a brief overview of the scoping document that we have put together. As you can see, it's focused on barriers, challenges, and opportunities for chemical companies to set science-based targets. And it's more comprehensive and lengthy than we had initially expected when we started this project. So it's about 80 pages, and it covers a good range of issues in the upfront text, but then in great detail in the 6 appendices that we've added to the document. And so I would encourage folks to take a look at the front sections if you're interested, and if you really want to see the details and understand what we found in the survey and other technical aspects of what we're presenting today, those are presented in great deal in the appendices. So now I'm just going to pivot to giving a little bit of a Science-Based Targets Initiative update to give some context for what we'll be talking about today. So the next slide gives you a summary of the Science-Based Targets Initiative by the numbers these days. So you can see here, this month we blew past, within the past month, we blew past our goal for 2020 of having 1,000 companies publicly commit to setting science-based targets. Now we have 1,100 companies and financial institutions that have publicly committed. And among those, we have more than 540 that have set targets that meet all of our criteria. And these criteria have evolved over the years, and now there are more than 20 criteria that companies and financial institutions need to meet in order to have one of these approved targets. I would note that at this point, we have almost 20 companies joining the initiative per month. So there's certainly high uptake of science-based targets across sectors and geographies. And the value of the companies and financial institutions that have joined is approximately $15 trillion. So this is getting to be a significant portion of the global economy. And we have many large companies. So we have about a fifth of the global Fortune 500 companies that have committed or set targets so far. So we're seeing very rapid uptake of science-based targets within the economy across sectors. The next slide shows the numbers and the companies that have joined within the chemical sector. And initially, we did have some slow uptake in the first couple of years of the initiative after we launched in 2015, but now it's really starting to speed up. You can see here's the list of the 28 chemical companies that have committed to setting science-based targets, and the ones that are listed here in bold, such as Borgard, Ecolab, Novozymes, Royal DSM, International Flavors and Fragrances, Sekisui, Sumitomo, Syngenta, and Tata Chemicals have targets that have met our criteria. And what's notable here is that these are chemical companies that have met our broad company criteria with no special intensity pathways or criteria for chemical sector per se. So this shows that there is an ability of the chemical sector and various companies to actually reduce emissions while continuing to thrive economically, which is great. That's part of the central thesis of the Science-Based Targets Initiative. At the same time, we do recognize that there is a need for additional resources, and we do want to see this group grow very quickly to include other chemical sector players and companies. And so that's why we are focusing on this project, the scoping project. So these 10 companies that have set targets are great leaders, and we expect that group of 10 to grow to include at least these other companies that have committed, but also other chemical companies. One other thing to note is that this group is very diverse, and this is a higher level of diversity than we see in many other sectors. So we have companies from 15 countries across 5 continents here. So this is great. It really shows the global scope of action in the chemicals sector, and that this is not just a particular region using policy to drive chemical company ambition in one particular country or region. That's not to say that policy doesn't play a role here, but that companies are moving on their own to take these targets and actually set targets. And so this is some of the context for what we're talking about here today. So the next slide just gives a little bit more information about the companies that do have targets in terms of how they have set those targets. You can see here that 2 of the companies, Novozymes and Ecolab, have targets that meet the Science-Based Targets Initiative highest level of ambition. That's 1.5 degree aligned targets. And for the scope 1 and 2 portion of their targets, they're absolute reduction targets, which means that they're quite ambitious, generally above 4.2% per year annual reduction of scope 1 and 2 emissions. And then for scope 3, there's a range of target types. And so you can see here that Novozymes used an absolute target, whereas Ecolab used a supplier engagement target. And clearly this will vary depending on where companies are in their value chains and what mitigation options they have at their disposal. And so the Science-Based Targets Initiative does provide some flexibility there for companies to navigate that. So at this point, I'm going to now pivot and hand it over to my colleague, Kylie Chang, to provide some discussion on the results of the stakeholder survey.
Thanks, Nate. So I will talk about the stakeholder survey that we conducted this summer. And it was a public survey to gather chemicals sector stakeholder feedback on the challenges and opportunities for setting science-based targets. And we gathered information including perspectives on scope 3 data and the sector's low carbon transformation. So the detailed survey results, as Nate mentioned, is included in our final publication, which we will be distributing shortly after this webinar. And just in summary, the survey was completed by 59 respondents, and of which 40 respondents worked for a chemical company, and 8 of those companies specified that they produce products that do not result in end-of-life emissions. So additionally, we also had some companies with multiple respondents, but we analyzed the individual responses for analysis purposes. And just in the results, which I'll go over next, a lot of chemical companies indicated a variety of challenges to setting their science-based targets. So first, the top issue referenced by survey respondents is the low availability and quality of Scope 3 data. So the diversity of products across supply chains compounds the Scope 3 challenges faced by chemical companies. So respondents suggested that this could be improved by making relevant data available in a centralized and automated manner. And from an SBTi perspective, we do currently accept screenings and estimates of Scope 3 data, but as a forward option, we will consider how to provide more resources on how to improve limited and low data quality. The second issue identified was that some chemical companies have expressed a preference to postpone setting a science-based target until sector-specific physical intensity or other methods become available. And so this project does reflect the initiative's recognition of the sector's importance and our intention to develop further resources. But as shown in previous slides, many chemical companies have used existing sector agnostic methods to set science-based targets. And in general, the SBTi does not view a lack of physical intensity method as an excuse for company inaction. So the third issue that we identified is that respondents noted that it is not easy to decarbonize in the chemical sector, as there are complexities and challenges that are very unique just to the sector. So for example, the technological readiness of low carbon technologies are not ready to be deployed on a commercial scale to abate the sector emissions at a rate required for well below 2C or 1.5C pathways. Additionally, other layers on top of that is that there are a lot of business model uncertainty and uncertainties around policy that cover future costs of greenhouse gas emissions, and chemical companies raised this during our survey. So the takeaway here is that, as a chemical company, it's not that straightforward to decarbonize. And in our scoping document, we do explore how the initiative can best address these issues, along with the net zero standard that will be released in 2021. We hope that this will help to address some of these issues. So the fourth issue that we identified was that chemical companies vocalize that more cooperation over the value chain is needed, especially given the difficulty of accessing primary data on downstream emissions. So chemical companies also expressed that delivering on Scope 3 targets is outside of a chemical company's control due to limited leverage and high diversity and limited data availability. So while the first group of leading chemical companies have already set Scope 3 targets, the initiative does recognize that increased engagement with investors, advocacy groups, and other stakeholders will be important for catalyzing broader cooperation across value chains. The other issues not specified in the survey, but we identified through our conversations with our expert advisory group and other chemical companies is how to deal with the emissions intensive growth of the sector, the 5 to 15 year timeframe of science-based targets, where chemical companies have expressed concerns about emissions lock-in and stranded assets. And one company suggested differentiating large and other companies based on total emissions footprint to reflect mitigation feasibility. So I can't go into detail here, but we have addressed how to deal with these concerns in our scoping document. And last, just aside from the challenges, in general, chemical companies indicated that they do have data on their scope 1 and 2 emissions from combined heat and power, self-generated electricity, process emissions, and fugitive emissions, but that these cannot be easily bundled together when considering emission reduction pathways. And so in our scoping document, we do provide suggestions for addressing each of these emission sources separately, including integrating the chemical sector, electricity, and related emissions with the SBTi SDA power sector pathway that we just released this year, to develop more resources on combined heat and power, separating process emissions using different target trajectories, and also providing additional methods or requirements on fugitive emissions. So those were the barriers and challenges identified by the survey respondents, but one issue that I want to mention that was consistently brought up but is not on the slide was the sector boundary between the chemical sector and the oil and gas sector, and how to properly and consistently account for feedstock related emissions. Over 50% of respondents reported using at least one existing sector classification and methodology, while many use multiple sector classifications. So during this project, we tried to address any inconsistencies between these two sectors, and I'll pass it to Michiel to talk more about the demarcation of the chemical sector.
Thank you, Kylie. And this is Michiel Stork speaking, Associate Director at Guidehouse. Let's first wonder a bit why it is important how the chemical sector is scoped, how the boundaries are defined. And obviously, when a target is set and when there are different approaches and pathways for each of the sectors, it matters where your company's activities are. And of course, there are integrated companies who start all the way as a refinery and deliver quite some specialized chemicals. So somewhere there will then be a sector boundary, which in some cases will also mean that companies would, for the SBT determination, consider their activities in the refinery sector separately from their activities in the chemical sector, or maybe their activities in the chemical sector separately from their activities in the application sector, should they have these. So the scope, of course, matters in terms of what does this methodology apply to. Let's go to the next slide, please. The survey result, as Kylie already mentioned, resulted in the insight that many companies are, of course, using a taxonomy, a way to classify the activities they are doing. But there was not a clear preference for one specific taxonomy in the survey. We asked for that because if everybody would have used the same taxonomy, the same sector classification to categorize their activities, then that would have been an advantage to take that same methodology to make life easy for the companies that are considering setting targets or setting targets. There was not one clear taxonomy that beat all the rest clearly. It was more of a mixed bag. We also specifically asked whether or not there was a preference to include biofuels and pharmaceuticals in the chemical sector. For biofuels, that preference was relatively clear. based on the logic that biofuels are often produced integratedly with bio-based chemicals. And for pharmaceuticals, there also was a preference, less outspoken, based on the thinking that it's similar processes to make some specialty chemicals and pharmaceuticals. The expert advisory group that Nate already mentioned considered that this missing overarching taxonomy is a target to setting, is a barrier to setting targets. So based on that, we thought it was worthwhile to spend quite some time thinking through how the chemical sector should be demarcated. SBTi currently uses the IEA's energy technology perspectives modeling in the STA method, and the IEA in their ETP uses the ISIC classification, with the chemical sector covering both division 20 and 21. And that kind of means that pharmaceuticals are included, but biofuels are not included. So based on the current modeling used, we thought it would be logical to remain consistent so that there is the option to continue using that modeling when diving deeper in the chemical sector. That means that pharmaceuticals would be included in the chemical sector scope. That does not automatically mean that pharmaceutical companies that have already set targets will be asked to do that again. It does also mean that biofuels, which are in the energy transformation sector in the IEA's modeling, it means that biofuels are not included in the chemical sector demarcation that we are working with at this moment. Finally, there's one subsector that indicated that they preferred to be covered as a separate sector or subsector. And I think if we would have asked the same question to more subsectors, we might have received more of these answers. Let's go to the next slide. So this slide is our attempt to make clear what chemical processes are happening and how they relate to the upstream, scope 3 oil and gas sector, and how they relate to the applications, scope 3 downstream. Obviously, as you see, marked by the dashed orange line, the chemical sector is the scope 1 and 2 part in the middle. This is not a complete picture. We are well aware that the chemical sector is much more complex than can be shown in a visual like this. So we left out many of the processes, we simplified, but we thought this was a useful picture to show where we see the demarcation between the chemical sector and the upstream sectors and also the downstream sectors. Also, it contains current production processes, but also a few typical future production processes. So if we just touch on some highlights, you see in a refinery that benzene, toluene, xylene, BTX, fuels, naphtha, NGL, LPG, propane, propylene are already produced. The naphtha is converted to a naphtha cracker. In a naphtha cracker, BTX, propylene, ethylene are also produced. You also see that a natural gas on the right side is converted using steam methane reforming to syngas converted to ammonia. All these cracker products, so BTX, propylene, ethylene, ammonia, are converted to polymers, specialty chemicals, consumer chemicals, solvents, pharmaceuticals, a whole range of chemical products. And you see indeed that pharmaceuticals are included. Syngas can also be converted to methanol, a key chemical of the future as well, I think, which is then also converted to applications. You see that all these polymers, specialty chemicals, consumer chemicals, and so on, that they are all converted to applications, and that the applications can be mechanical recycled or chemical recycled, where we had two example processes, pyrolysis oil back to the cracker, and all the way to the right, back to gasification, back to syngas, from which again these products can be made. You see that by adding power, green hydrogen can be made. Combining that with CO2, there's the carbon capture and utilization, from which methanol can be made, which can then be converted to the cracker products again. But it can also be directly converted to the polymer specialty chemicals and the full range of chemical products. And you see biomass through various routes in the visual as well. A couple of remarks. In the refinery, you see that catalytic reforming is used to produce benzene, toluene, and xylene, and FCC is used to produce propylene. Our thinking is that this is an integrated part of the refineries. So the BTX production and the propylene production there is part of the oil and gas sector, while the production of benzene, toluene, xylene, propylene, ethylene in the chemical sector itself, in the crackers, is part of the chemical industry. You also see in light blue that the benzene, toluene, xylene, propylene, ethylene, ammonia, methanol, and hydrogen, that these are key products. And it's on these key products that we think individual efforts should be focused to determine product-specific pathways. These products together are the basis for most chemicals, although there are direct routes, for example, from biomass or using CCU to the products like polymers. But the products in light blue are the building blocks of by far most chemicals, and they are responsible. Their production is responsible for a significant share of the scope 1 and 2 emissions of the sector. So based on these considerations, we think it makes sense to focus the development of individual product pathways on these. All of these are also the focus of the individual products modeling of the IEA, apart from hydrogen. Hydrogen we added not so much because of its current role, because its current role is mainly limited to methanol and ammonia, not entirely. And that is covered already, but because we see a larger role for hydrogen in the future of the chemical industry. So we thought this should be a chemical that deserves separate attention on top of the 7 that the IEA already has. So summarizing, catalytic reforming and FCC producing BTX and propylene in the refineries are part of the refinery sector as we see it. The cracker production is part of the chemical industry, and the light blue 8 chemicals deserve individual attention in an individual pathway. Let's go to the next slide. The next slide makes somewhat clearer what the focus of the chemical sector is. And once again, you see the pharmaceuticals in, biofuels would not be in. Let's go to the next slide. So when disaggregating the chemical sector, the first thing we would likely do is split it up in subsectors, or as the expert advisory group suggested, product groups. So typicals such as fertilizers or plastics or solvents, and based on these make specific pathways which are not individual product specific. There are simply too many products for that. And then carve out the specific 8 products that I already mentioned that were in light blue and that you see here again. And the distinction between refineries and chemicals is summarized here on the right side of the slide. The remark at the bottom of that slide basically says, we are aware that we say that propylene is partly produced in the chemical sector, partly in the refinery sector, likewise for BTX. And we are also suggesting to make individual pathways for these. If we discover that making these individual pathways becomes very illogical to have them in separate sectors, then we might reconsider that again. Let's go to the next slide. Then in the chemical sector, the end-of-life emissions are also very important. And I think this is also something that makes the chemical industry stand out, because many chemicals, when they are at the end of life and when they would be incinerated, many of these emit greenhouse gases as a consequence of burning that, as many of the chemicals are or contain hydrocarbons. So that's different than for many of the other materials. And that makes it logical that when you develop something specifically for the chemical industry, you pay more attention to the end-of-life emissions than maybe you would have done for any other sector. So we had quite some focus on that. Can we go to the next slide? Basically two elements caught quite some attention. And there's much more to read in both the main text and the appendixes of the document that will be shared next week. So I hope you find that a good read. But one of the topics is, Kylie already mentioned that the amount of data available for chemicals in scope 3, so what happens end of life is part of that, that data availability is relatively limited. Not all companies know where all their products end up, to put it relatively mildly. That also means that there might be a need to work with typical data. Typical data could, for example, be in a specific geography. The way plastic waste is processed is typically, say, 20% is incinerated and 80% goes to landfilling. Now, the first thought when you think about that landfilling for end of life is, of course, what will the future of landfilling be? In Europe, the aim is to strive towards zero landfilling. So is landfilling still going to happen? If not, if it would be incinerated, that leads to the emissions that you get when you burn hydrocarbons. But if you focus a little bit more on the landfilling for now, then for durable plastics, the World Business Council for Sustainable Development methodology says you can kind of assume zero emissions. While for non-durable plastics, the assumption is 50% of the carbon in hydrocarbons would be converted to methane, and 50% would be converted to CO2. Now, methane is a very powerful greenhouse gas. So the consequence of the difference in emission factors based on a typical approach would be more than a factor of 50. So if you have a plastic that is or maybe is not durable, then the end-of-life emissions differ with more than a factor of 50, dependent on whether it is attributed durable or non-durable plastic status. So we think that moving further, it is relevant to better understand how to deal with this factor 50, which is a big factor for something to be treated with typical data. The second point is accounting methods. If you look at the visual that you see, then you see chemical plant A producing plastics. This plastic is used, for example, as food packaging. It is then recycled. It is returned to the chemical industry and converted again into plastics, which is used and then, let's say, landfilled for the sake of this discussion. And the question, of course, is who gets the benefit of this recycling effort? Is it company A who can say, my end-of-life emissions have been avoided as a consequence of this recycling? Or is it plant B who can say, well, I know that my plastic at the end of life has been disposed, but has been landfilled or incinerated, but I used recycled content. I used raw materials that were recycled. Obviously, if plant A is owned by a different company than plant B, the scope 3 emissions of plant A and B are impacted by the decision who gets this credit. And this world is not black and white. It could also be that a combination of approaches would be the best approach. Current guidance, I think, is not yet fully conclusive of what should best be used. And I think there are pros and cons to both approaches. And if we go to the next slide, then we get to the question, now how would this play out for chemical companies in the target setting, chemical companies who have products that end of life lead to a category 12 emissions, so to greenhouse gas emissions. And basically we made a distinction between the scope 3 target when end of life emissions are relevant could be an end of life target. So for all the products that you make as a chemical company, you would need to think through and work your way towards reduction of the emissions of these chemicals that you produce. Or alternatively, as the expert advisory group suggested, you could have a circular feedstock target, where you are more like company B in the previous slide, and where the question is, how much of your feedstocks are circular or renewable? Comparing these two, in the end of life targets, a company could, for example, meet that by engaging with waste processes to set science-based targets as well, to in that way tackle the emissions there. It could use an extended producer responsibility schemes, act on these, and many other options, I would say. Advantages of these in comparison to a circular feedstock target are that it's relatively straightforward and in line with the current approach. And it stimulates design for recycling, because if you design for recycling, it becomes easier to recycle your products, and thus easier to reduce end-of-life emissions. Secondly, it stimulates mechanical recycling, because in case of mechanical recycling, the end-of-life emissions would be avoided too. It, of course, would also stimulate chemical recycling, but a circular feedstock target does that as well, which is why it's not making the difference between these two. So that's why you don't see chemical recycling on this list. And it stimulates other new behavior, perhaps different business models that provide end-of-life emissions. A circular feedstock target would look at circularity and renewables. Could, for example, be expressed on an energy basis or a greenhouse gas mitigation basis. So what share of the energy content that you put in is renewable? Is, for example, based on renewable hydrogen, is circular, comes from recycling. Advantages there is that it's easier to be controlled by chemical companies. The amount of suppliers is more limited. It's still extensive, but it's more limited and more something that chemical companies decide themselves on than what happens with their products in the different markets. Also, we heard that an end-of-life target is difficult to meet because chemical companies make a high number of products which go into an even higher number of applications, which are sold in an even higher number of countries. So if you want to control all of that, that is more complicated than controlling the feedstocks that you purchase. And on top of that, the data availability for these flows and for all the applications in all the geographies is relatively limited. Finally, also important, it was the clear preference of the expert advisory group expressed to use a circular feedstock target. In the report, you will also find the very first initial attempt to sketch how such a circular feedstock target could potentially be determined. So once again, I encourage everybody to read the report. Next year, we will need to be more concrete in which of these or which combination of these two to choose. And with that, we are gradually moving towards next steps. And for that, I would like to give the floor back to Nate.
Great. Thank you, Michiel. And glad to see folks are still with us here. That was a lot of technical information. So it's good that people have an appetite for the details here. So this is clearly a complex sector with its own specific issues, especially related to high feedstock use of fossil fuels, of oil and gas, especially the broad variety of products and the high degree of intermediate product trade here creates complications well beyond many other sectors. So the next slide just sort of puts this in GHG protocol terms, which are the basis for how we work in the Science-Based Targets Initiative. As Michiel and Kylie have described, the key categories here for chemical companies are really scope 1. That's generally where most of the emissions are for a lot of these companies. And so the sector boundary that Michiel presented is our way of having some consistency across companies, especially with regard to oil and gas sector discussions. As many of these companies change their product mix and their business models, it's useful to have consistent boundaries to understand where they are and which emissions belong to a particular company's scope 1 as opposed to the scope 3 of another company. The 4 key scope 3 categories that have come up in this project are category 1, purchase goods and services for those downstream companies. But even for just the regular chemical companies, as Michiel showed in the sector boundary figure, those purchase inputs from the oil and gas refineries can really vary in terms of how they're produced and the emissions intensiveness of their production. So there is a case for chemical companies to have category 1 intensity or other targets. And then of course, as Michiel was just describing, the end of life treatment of chemical products is essential given the amount of fossil fuel that's included in them as feedstocks within the material itself. And so how category 12 and category 1 interact in terms of any crediting for recycling or other activities is a key question for the sector. There's also a lot of questions around use of sold product and processing of sold products that companies were expressing. So in terms of next steps, we have identified 3 main focus areas for the next phase of work. The first is to develop physical intensity methods for these 8 chemical categories that Michiel mentioned. So ammonia, ethylene, methanol, polypropylene, BTX, and hydrogen. Hydrogen being a new addition that would probably require some additional research in terms of the various routes that are out there, but obviously we're referring to green hydrogen in this case, not methane steam reforming. This is clearly an area that many of the chemical companies and other stakeholders have identified that would help to accelerate ambition, not only for the chemical companies themselves, but also for the purchasing companies downstream of the chemical sector, and also for financial institutions that are looking to start to screen and be able to identify the performance of different chemical companies and benchmark their performance from a climate perspective. Obviously, another area here is the scope 3 data resources, especially around those 4 categories that I mentioned. And there is some related work that Kylie mentioned regarding the net zero standard that the Science Based Targets Initiative is developing in terms of the treatment of bioenergy and biomaterials for chemicals companies and chemicals production processes. And then finally, this 3rd area, developing end-of-life accounting and target setting approaches for chemicals, is a key one that is unique to the sector because it uses so many fossil fuels as feedstock. And so this is another priority for our next phase of work. The next phase of work depends largely on these 3 factors. So really funding is key. And we, as I said, have been very fortunate to have very enlightened funding, generous funding from 3M for this scoping phase of the work. And we do hope to find additional funding for continuing the work and focusing on these areas that we've described today. The ideal setup here would be a consortium of companies or perhaps financial institutions or industry associations or other stakeholders in order to maintain the relevance and broad applicability of this work. And so that's really what we're aiming to do now, and we're in conversation with some potential groups. But if any of you listening to this webinar have interest in supporting this work, please let us know. Another key factor here is external collaboration. And so Michiel mentioned the IEA as a reference for the sector boundary that we're presenting here, and as a basis for some of the SBT initiative's previous physical intensity work with the sector decarbonization approach. We're seeking broad external collaboration. We had a question from one of you regarding industry association outreach, and certainly we do plan to reach out to them further. We have consulted with a couple of them so far, but the broader the better. I mentioned that we have 15 companies that have 15 countries that have chemical companies that have committed or set targets. And we see that as a really good sign here. We do want this to continue to be a global project and initiative. And so if we can include a broad group of collaborators, that helps to maintain the relevance and scalability of this work. And then finally, the Science-Based Targets Initiative strategy is an important component here in terms of our limited resources and how this links with our other strategic objectives, such as further clarifying the link between science-based targets and net zero targets, and compensation and neutralization, and these broader questions around net zero, which are pressing questions now given the very high popularity of net zero targets. So these will all influence the way and level at which we proceed with this work next year, but we hope that it will include all of you that are interested in working with us. The next slide just gives a screenshot of our chemicals project website with the Science-Based Targets Initiative. And this is where you can find a recording of this webinar, as well as the slides from today, and the scoping document itself will be uploaded there. It will also be emailed to all of you once it's ready in the next few days. That project website also includes a sign-up link where you can join the stakeholder list if you're not on it already. If you want to keep being updated on new developments in the project, I would encourage you to join the email list. With that, I think this is the final slide. So we'll just open it up to see if there are questions that we can address in the remaining few minutes. So let me see. I see that we've had some about the publication, so I think those have been answered. Michiel, do you want to provide an on-air answer to any of these other questions that you've answered in writing?
I think there were a couple of questions on the individual products. I think indeed high-value chemicals could be used as a cluster rather than going for ethylene, propylene, BTX separately. That has pros and cons. But maybe we focus on the questions that are still open. And from that, I take out the question whether the accounting process is going to account for the percentage of material that is actually recycled rather than the potential recyclable. I think the potential recyclable is an interesting one, because it also depends on to which extent you design for recycling. So in an end-of-life approach, I think it is just about what happens with the materials end of life, and not about whether or not something can be recycled. And if it cannot be, and you cannot decrease sufficiently deeply, then maybe new processes or new materials would need to be designed or chosen. And the percentage of material that is actually recycled, that sounds more like the percentage of material, the percentage of feedstock that is recycled that goes in rather than goes out. I hope that answered the question that Max asked. And maybe Nate, Tim's question is a question for you. You're muted.
Yes. So Tim says a coordinated effort at industry region level is critical for sellers and buyers to drive scale. Agreed. So I mean, I'd say this has been the signal achievement of the Science-Based Targets Initiative, is to get companies to quantify and address their Scope 3 emissions. And indeed, I think that's what's driven a lot of the chemical companies to set targets, is that their purchasers are increasingly requesting this. And so we do try to take a system approach to this. And we are pleased to have the diversity of companies so far, but I think we could use more industry association and upstream and downstream sort of oriented balance here. Say generally within the SBT initiative, the downstream consumer-facing companies are the ones that join first, and then it gradually percolates upstream. And we're seeing a similar pattern with the chemical sector. But of course, we want to engage those large upstream producers. The large scope 1 emitters are the goal here. And so this is something that we discussed in the scoping document you'll see. And if any of you have ways to do that, or you work for a large upstream chemical producer, then please get in touch and set a target. So I think we have a few more questions. Yeah.
Let me take the next one, which asks whether I propose to do the circular feedstock approach and not the end-of-life approach. Right. Actually, that was not what I was trying to propose. When I started or was halfway of this project, I thought this would be the best way forward. Now I think there are pros and cons to both methodologies. So I don't think it is already decided what to do, and maybe a combination would be the best way, or maybe flexibility would be the best way. I think we got quite far in exploring the two, but I don't think a decision already has been taken on what will happen with that one.
Thanks, Michiel. I'll take this this one from Phil, and then you or any of the other panelists can jump in. So Phil asks, if every entity aims for a net zero on scope 1 and 2 target, then scope 3 becomes less important. Will the chemical sector approach still keep the clarity of the general SBTi method on scope 1 and 2? Yes. So indeed, all emissions globally are scope 1. The reason that we use scope 2 and scope 3 is to identify these value chain relationships and keep this systemic perspective. But we have maintained pretty strong consistency in terms of the scope 1 and 2 requirements across sectors, and we expect that to continue with the chemical sector. I think that you'll see in the scoping document that there is some discussion of recycling, end of life, of course, and how that can come in for new feedstock purchases, but that's all scope 3, but it does affect the scope 1 potentially. So there are some trade-offs that we identify. And then, of course, treatment of biofuels is a big question. So the answer is yes, with some sort of special attention to chemical sector characteristics and realities.
Let me take the next question, which is about chlorine not being considered. With the question, is it because of related absolute greenhouse gases are significantly lower? It actually is a good point. Chlorine production, of course, uses electricity and not so much, doesn't lead to so much scope 1 emissions if the electricity is procured. Electricity is expected to decarbonize relatively quickly, but it is a fair challenge, I think. So point taken. Then I see a question, what about composting as end of life and incineration with electricity recovery? How is that considered? I think the value in terms of greenhouse gas of electricity recovery will decrease over time because the emission factor of electricity will be lower. And for the composting part, I refer to Nate. You didn't see that coming, sorry.
Yeah. I think that this is still relatively small scale, but I mean, generally, we support these holistic solutions, including composting. I think, we'd have to look at how that scales in terms of methane emissions and timeframes of accounting and how the crediting works. But yeah, I mean, I fully support composting, and we would want to incorporate it somehow. I mean, this is part of the broader challenge of this initiative, is that we work in emissions terms. And that's the science for science-based targets, is climate science in terms of greenhouse gas emissions. But there are many other laudable goals that we support, but that can't always be shoehorned into the emissions terms that we use. And the accounting mechanisms aren't always fully developed for how you attribute any reductions across these different activities. So I think it's something that we could explore as well. But I haven't had it brought up by many companies so far. So it's an issue of sort of priorities and what we do first. I saw a question Thank you, by the way, for all these great questions. Unfortunately, we're running out of time, so I don't think we have time for a whole lot more, but I saw one on the link with NDCs, and that is a broader question in terms of company emission reductions and country emission reductions, and it's one that the initiative is also thinking about in terms of policy linkages, and I think this will also be covered partially in our net zero standard. Any final words, Kylie or Michiel?
No, thanks.
Okay. Well, thank you again, everyone, for joining and for sticking with us here. It's been a lot of information, so I hope that this is useful to everyone and that you'll check out the scoping document when we send it to you shortly. And for those of you who work for chemical companies that have not yet set targets, we would encourage you to reach out and set a target. And wish everyone a happy holiday season and New Year. Thank you for joining.
Thank you.